We're going to start this application by importing some modules, of course. The subprocess module will be useful for issuing a Linux command from within the Python application. We'll see that in a moment. The logging module will provide a method to suppress any warning messages generated by Scapy when running the application. Random will be used to generate some random integers. And finally, the sys module will help us to instantly quit the program using the exit function. Now notice that before the import statements, I've added a multi-line comment showing the packet format for various DHCP packets, which I have extracted using the command method in Scapy's interactive shell. To freshen up this topic, you can revisit the Python networking with Scapy lecture. Just keep in mind that this method actually recreates an existing packet, a captured packet, and returns a string that you can edit and that is ready to be passed into a function and sent on the wire. Okay, the next thing I did is I used the method from the logging module to suppress all Scapy messages that have a lower level of seriousness than error. This will help us have a nice and clean output because sometimes Scapy generates some warning messages when you either try to open the application, the interactive shell of Scapy, or if you are using Scapy related functionality within your programs. So these methods right here will suppress any of the warning messages that we can see or might be generated at some time by Scapy. Okay, one more thing about these settings. They should always be made before importing the Scapy module itself. That's why right below them, using a try except block as an improvement to the user experience, I went ahead and imported Scapy using a from import statement. Next, just to have them at hand, I did a short recap of the Scapy interpreter commands using the hash sign for single line comments. Okay, after printing a message to the user that it should run this application as root, let's see the reason behind this suggestion I'm making. Because we will simulate DHCP clients and their MAC addresses that don't really exist on our computer, we need all the traffic that is received by the networking card to be sent to the CPU for processing, regardless of the destination MAC address in the frames we are receiving. That's why we should set the network interface card to promiscuous mode. Otherwise, only the traffic that is really intended to our real network interface card or MAC address will be permitted. In Linux, this can be configured using the command ifconfig, the name of the interface, and promisc, and only having root privileges. That's why the user should run this application as root. But that's not all. In VirtualBox, you should save your work, turn off the Debian virtual machine, and go to Settings, Network, the adapter you are using to connect to the GNS3 network, and set this field over here, promiscuous mode, to allow all. Then click on OK, and then restart your machine. Now you're almost good to go. I've talked about this setting in the README file that I will attach to this lecture. So we ask the user for the interface on which to set the promiscuous mode using the raw input function, and then using the call method from the subprocess module, we issue the Linux ifconfig command, the same way we did with ping. Notice this time I've added some other arguments to the call method. stdout and stderr refer to the program's standard output and standard error file. Setting them to none means no output or error redirection is desired when issuing the ifconfig command. Shell refers to the case in which you want to invoke a specific shell within Linux. We'll set it to false just to keep things nice and smooth. The last thing here is this conf.checkIPADDR equals false setting. As stating in the comments above it, Scapy normally makes sure that replies come from the same IP address the packet was sent to, but our DHCP packet is sent to the IP broadcast address, all 255s, and any answer packet will have the IP address of the replying DHCP server as its source address. For example, router R1's IP 192.168.2.101. Because these IP addresses don't match, we have to disable Scapy's check with this setting before sending the packet.